Morning, everyone. Myself, Srinath. I am working as assistant professor in the Department of Electronics and Communication Engineering at St. Peter's Engineering College. Today, I am dealing with basics of the semiconductors. Basics of the semiconductor. Semiconductor. Okay. What is meant by system? First of all, what is meant by system? System is a group of physical components arranged in a group in such a way that produces a practical output is known as system. System is a group of physical components arranged in a group in such a way that produces a practical output is known as system. What are the basic physical components to produce any control any system means resistance, inductance and capacitance are the basic physical components of the system. Resistance, capacitance and inductance are the examples of the system. This is input and this is output. Okay. Next, basics of the semiconductors. Semiconductors is started from electronics. Electronics. What is meant by electronics? Electronics is nothing but to study of motion of charge carriers in a semiconductor material, that is electronics. To study of motion of charge carriers in a material is nothing but electronics. Electronics is equal nothing but electron plus mechanics. To study of motion of charge carriers in a semiconductor material, that is electronics. Next, electronic device. Electronic device. The device which is made with semiconductor material, that is electronic device. The device which is made with semiconductor material, that is electronic device. Examples of the electronic devices means diode, transistor and silicon control rectifier. These are the examples of the electronic devices: diode, transistor and silicon control rectifier. These are the examples of the electronic devices. All electrical and electronic characteristics of the electronic devices are classified in two types. Electrical characteristics are depends upon the two types. First one is the active device, and second one is the passive device. Based on the electrical characteristics, semiconductor devices are classified in two types. What are they means? Active device and passive device. What is meant by active device? In any material which can act as a source of energy. Examples of the active device means all current source and voltage source are the examples of the active devices. All voltage and current sources are the examples of active devices. Next, passive device. Passive device is nothing but to dissipate the source of energy levels. To dissipate the energy. Example, transistor. To dissipate the energy, that is nothing but transistor. All current source and voltage source are the nothing but the active device, and dissipate the energy means transistor. Next, energy level splitting. Energy level splitting. In energy level splitting is nothing but from conduction band to the valency band is nothing but energy level splitting. It is denoted by energy gap. In Fermi level devices, conduction band to the valency band, the energy level is nothing but energy level splitting. For example, this is a one material. This is conduction band. This is This is valency band. The gap is nothing but energy gap. This is conduction band. This is valency band. For example, Eg is equal to EC minus EV. This is the basic principle of the Fermi level splitting. Eg means energy band gap. Here EC means bottom energy level of the Fermi level splitting. EV means top level of the energy level splitting. For example, electrons in the outermost orbit is nothing but valency electrons. Valency electrons means energy electrons are present in the outermost orbit is known as valence electrons. Valency is the number of outermost orbit in the valence electrons. For example, silicon has 4 valency electrons. Silicon has 4 valency electrons. For example, 1s2, 2s2, 2p6, 3s2, p2. This is the valence electrons present in the outermost orbit. Silicon has 4 valence electrons. Mixing of the third group and fifth group elements are nothing but elementary semiconductor devices. Only fourth group elements are nothing but compound elementary semiconductor materials. This is the energy level splitting. Electrons outermost orbit in the valence electron is nothing but valence electrons. For example, from conduction band to the valency band, conduction band to the valency band. In valency band, there are some holes, some form of vacancies are created in valency band. These vacancies are nothing but holes. These vacancies are nothing but holes. In conduction band to the valency band, some vacancies are created in the valency band. These vacancies are known as holes. These vacancies are holes. Next, semiconductor material. Semiconductor material. Semiconductor material can be classified in 2 types. What are they means? First one is the intrinsic semiconductor. Intrinsic semiconductor. Next one is the extrinsic semiconductor. Intrinsic semiconductor is nothing but it is a pure form of semiconductor. Extrinsic semiconductor is nothing but impure form of semiconductor. It offers low conductivity. This is the symbol for conductivity. This is the symbol for conductivity. It offers high conductivity. Extrinsic semiconductor offers high conductivity. Examples of the intrinsic semiconductor means silicon or germanium are the examples of intrinsic semiconductor. Extrinsic semiconductors of the examples are p-type material and n-type material. P-type material and n-type materials are the examples of n-type semiconductor material. Next, doping. Impure form of semiconductor material. Doping is nothing but doping is a process of adding the impurities to the pure form of semiconductor material is known as doping. Doping means adding the impurities such as pentavalent impurities and trivalent impurities, such as adding the extra impurities to pure form of semiconductor material is known as doping process. This is the semiconductor material, introduction to the semiconductor material. Okay, we'll see next class. Thank you.